Hey everyone, it's Jason here. Now, as you can see behind me, I have a periodic table. Now, isn't it just absolutely amazing? This periodic table is the first one in history that I have had in this room that is utterly and fully complete. And I even quite like the layout. I like that they've taken the lanthanides and actinides and they've actually put it neatly underneath here. Not many do that. They have a gap, and I don't like the gap. And I also love that all the freshly named elements, right, are all named. No more there's unum octium, unum septinum, unum unum, they're all named. Even carbonicium, which can typically not be named on other periodic tables, right? Well, these ones are all named. And I love the fact that for elements that they can actually at least find in nature and such, have pictures and images of them to go with them. Those that don't, like the radioactive ones, will have perhaps a face of person that discovered it or named it. They'll have a scientist that it was named after here, or they'll just have an atomic arrangement demonstrating what the atom with its electrons would look like. Now, I just love it. I think it's great. And they've also got all these different colours for each sort of group, and they've got a key here. You won't be able to see the key, but there's a key. And this key actually gives names to the groups. So for example, the key says, well, here you've got the transition metals that are all in orange. And the carbon group, the nitrogen group, oxygen group, the halogens and noble gases. Alkali metals, alkaline earth metals. We've got hydrogen in a group all of its own, actinides and lanthanides, actinides. And yeah, so I've just gone through them all. Okay, so I think this is amazing. Now I want to talk today about some of my favourite elements. People often ask me all the time, well, what's your favourite element? And I really have an answer because there's so many that I really like for all different reasons. And I want to go over a few today. So I'll start with one that I like. One of my favourite scientists, who's actually on this poster, is Einstein, Albert Einstein. Now we all know how small he was. He came up with the theory of relativity. Now I know that relates to nothing of chemistry at all, but why not put him on there? Because he's a scientist, you know, a physicist, and he's got a cool name, Einstein, Einsteinium, who could refuse? He's got a cool hairdo and a scientific moustache, and I like Einsteinium because of the name. That's about all. I've never felt Einstein, I've never touched him or the element, because he's been dead for a while. Now another element that I like is this one right here. Uranium. Now this is named after Mercury, which is a Polish scientist, and she was a woman, and she was the first scientist to attain a Nobel Prize, back when it was worth something, a Nobel Prize in two separate fields, in physics and chemistry, for discoveries of radioactive elements, along with her husband. But it's not that specific reason, though it is bonus why I like it. I like the name because it sounds like cure, you know, like curing something. And I think in this world, that's something we all want to aspire to, curing people. Okay, so another element that I really, really like is copper, Cu. Not because it's got a stupid chemical symbol, Cu, because it's copper, C-O-P-P-E-R, but because of the versatility of colour, basically. Now, as you know, we do use coppers and wires, and it was useful for a long time in wires before Wi-Fi. But copper has also traditionally been used for ornamental pieces. Now, the most famous of all, isn't it just the Statue of Liberty? Now, I love the Statue of Liberty. I love the look of it. I love what it stands for, New York, on Liberty Island. And I think it's a wonderful statue, and it is coated in copper. Not many people know this because they have this impression that copper is kind of like an orangey reddish sort of colour. It generally looks like that. You open up a wire, that's the colour you often get. But that's the beauty of copper, is that when it oxidizes, you get copper oxide, and that gives out a green appearance like jade. And that's one thing that I love about the Statue of Liberty. Living alive at the time when it was first made, set up, you would have seen it in this wonderful copper-like colour, its native colour of reddish kind of orange, and then it would have turned green. But even though it turned green, it looked even better than it was before. I think it stands out because it's green. Now another element that I really can't live without is oxygen. I really like oxygen. I breathe it in all the time, and even though I can't see it, I know it's going into me because I've read textbooks that have said you breathe in oxygen, and so that confirms it for me. Another element that I think is really good is gold. Now, I know that people like gold because of jewellery, but I don't have any gold jewellery. That's not why I like gold. I like gold not because it can be jewellery, but because it used to be a currency, and it used to limit the amount that money was stricken by, right? We used to have a gold standard, and people used to trade in gold bars. It had intrinsic value to people, right? Other than the sort of coins we get today, which can be made from cheap materials like copper. Not digging copper, because as I've mentioned, I do like copper. Now, there are 3 elements that I also like, and these 3 come in a group that is paired in a specific way with properties that make it so that I like it. And that is iron, cobalt, and nickel, right? I like those 3 elements, and they're together, right? But there's a very specific reason why I like them. It's because if you take a magnet, get this, if you take any magnet, it will stick to them, it will attract them. Any magnet in the world. Even Earth's magnetic field will influence it if it will influence gravity, right? And I just think that's fascinating. The idea that you can get 2 materials, bring them close together, and without even doing any more bringing together, they come together without your own hands. I think that's so fantastic. Now, another element that I like is uranium, right? Uranium is an element that I like, not because it's used in nuclear bombs, no, but because it can be used in nuclear fuel. To think that there's this element, right? This element where you've got this sort of fork in the road. You could either use it for such great evil or such great good is astonishing to me. And it kind of presents people all the time with this moral dichotomy, right? What do we use uranium for? Do we use it to go and blow people up? Or do we use it to supply energy, endless energy to the whole world? That is a very fascinating use of an element, if I do say so. Now, another element that has the same property is chlorine, right? People used to use it in chlorine gas during the war, and it would do so much damage. But on the flip side, smart people who wish to do good can use it in chlorinated water. It has helped salination like we've never seen before. It has distilled water and made it drinkable. Another element that has this dichotomy, you can use it for either great evil or great good. Now another element that I like, and this has a very specific property that I think is just amazing, is iodine. Now, iodine is amazing. If you have a block of iodine, it doesn't even wait to become liquid before it goes to gas. It's called sublimation. It actually sublimates, right? It actually turns to gas before it turns to liquid. Isn't that amazing? I think it's amazing. Now another element that has a cool property is mercury. Now mercury is amazing. You know why? Because if you have mercury, you don't even need to be in a sauna or a very hot room. Mercury is liquid metal, molten metal. It literally runs. You can pour it over yourself. It used to be used in thermometers. People used to be able to tell the temperature. What you'd have is the external temperature of the outside thermometer would vibrate the atoms in the mercury causing to expand. And that expansion in an enclosed container would present a certain calibrated value that would signify a temperature value. These used to be used in Fahrenheit, right? But I don't use Fahrenheit. I personally use Kelvin because I like to be scientific. Okay? Now that's mercury. Now, everybody knows that I love chocolate. I love eating chocolate. I eat it all the time, right? And if there's one element that I wish were chocolate because of its properties, or is most like chocolate, it would be gallium. Gallium Doesn't look like chocolate, I know, it's silver. It seems silver, and it is silver. But it does what chocolate does, in that it melts in your hand. And if you ever put it on your tongue, it'll do it the same as well. So it may start off as solid, it looks like a solid at room temperature, but you put it on your hand or your tongue or somewhere a little warm, and it starts to melt like chocolate. Amazing stuff. Oh my god, these are all just amazing. Other elements that I think are really, really cool for what they do is the alkali metals. Now, I'm sure maybe in science one day you maybe have tried this. You take an alkali metal like lithium, sodium or potassium, and you add it to water, and it starts to react very vigorously, right? It does. It starts to react with the water. Lithium can sometimes even flame a little, but the one that you guarantee to get a flame with is potassium, get a lilac flame. And if you ever do it in the dark, you'll see it just glow lilac. I think again it's amazing because we're so used to dealing with metal and being able to touch metal or spill water on metal and reasonably presume that it's not going to blow up. But with these metals, they do just that. They explode. And rubidium and cesium, they're even more explosive. As you go down the table, you get a bigger explosion. And it does everything of francium. Now, by the way, there's only 30 grams expected, an estimated amount of francium in the whole wide world of Earth, right? Only not the universe of Earth is expected to be 30 grams, right, of francium. Isn't it just nuts to think of one element? That's how rare it is. It's the rarest element francium is. So we don't even have enough francium to actually collect, distill, and throw in a bathtub to see what it would do, right? But if we did, I'm sure we wouldn't because it's so rare. We'd want to sell it for something else, right? Okay. Now, another element that I don't like. There's an element that I actually don't like, right? And it's not a thing against the element personally. It's just yeah. So another element I don't like is element 118, Magnesium. Now, if the name wasn't annoying enough to say Magnesium, it doesn't sound elemental, it's not got the EM in the end and all that sort of stuff, and it was named after Yuri, right? Who was the guy that actually discovered it. Now, I didn't want it to be named after the guy that discovered it, really. I think, because it was the last element, I mean, it's not likely that we're ever going to add another row to the periodic table, right? It's not likely that's going to ever happen, right? So, for me, I wish that they named the very last element, even if it was one of these, but I think significantly it should have been the last element. They should have named it after Isaac Newton, right? Now I get that Isaac Newton already has quite a lot named after him. He's got a unit named after him, like the Newton. He's got Newtonian fluid named after him. He's got his 3 laws of motion. He's got a lot named after him. But even still, he was such a significant and brilliant scientist of his day in the 1700s, right? That I think it was worth, if we're going to name an element after Einstein because of his name, well, Isaac Newton has that same similar quality in his name. Newton sounds amazing, and just think of an element called Newtonium, not like Newtonian laws of physics or anything like that, but Newtonium that ends in IUN, and you could easily know what the chemical symbol would be for that. Newtonium would be NT, right? And I think it's just a real shame that we named it after a nobody. No one knows who Yuri is. I don't. I never heard of him, right? I've never heard of him. Nothing against him personally, but I don't know who he is. Now, another element that I find fascinating. Let's get back to a happier note, right? Another element I find fascinating is carbon. Carbon is just amazing. Not only are all life forms on Earth carbon-based, none of them are found, nothing alive is found without carbon in it, right? Another fascinating thing. But I love the fact that carbon can be, with enough pressure, can become a diamond. Another amazing thing, right? You know, if you have coal, and I know it's a hydrocarbon, so it's got hydrogen, but you move the hydrogen and you then pressurize the coal, you actually get diamond with enough pressure applied, right? Amazing stuff to think that something that looks so sort of ugly and hideous in form could be something so beautiful in form, right? In the end, as you know, you've got graphite, right? Graphene, right? These are all allotropes of carbon, different atomically arranged structures with the same element, right? Of the same element. Allotrope is that particular way, but we also have isotopes. Now, hydrogen has 3 isotopes. That means it's, you know, they've all got one proton, right? But some have no neutrons, one has 2 neutrons and one has like 3 neutrons. So that's an illustration of the sort of things you get when you have hydrogen. Now another element, right? And it's one of the first elements that ever impressed me back at school was magnesium, over here. Because if you ever turn the lights off, like and were to burn some magnesium in open air with a Bunsen burner, you got this amazing blast of energy, this amazing light that would fill a whole room. It would be blinding to stare at. It was amazing to watch such a powerful exothermic reaction take place right before your very eyes. I really couldn't believe it when I first seen it. It really got me excited for chemistry. It did. It really, really did. So, and I mean, to be honest, I basically like them all. There are more elements I like. Obviously, I like tin because I like tin cans for, you know, storing food. And I'd like to go over more elements in the future. If you want me to do another video going over specific elements, just let me know. And I'll do that for you. Until then, I hope you've enjoyed a bit of my favourite elements. And till then, I'll see you soon. Alright, I've been saying goodbye.